So first we'll study about the peak inverse voltage. Do you know what is peak inverse voltage? As its name suggests, peak means maximum, right? Inverse means the like opposite. Okay, so it is basically the maximum voltage that the diode has to withstand. Okay, the maximum voltage, how much we can give to the diode. So maximum voltage, how much we can give? Peak inverse voltage is denoted by PIV and it should be equal to Vs max, right? Because it's a peak voltage na. So as you know, what is the supply voltage? Supply voltage waveform is like this. This is the standard equation will get V is equal to V max sine omega t. This is the supply voltage that is denoted by Vs, so it should be Vs max. So Vs max is how much? This one. Vs max is the maximum of the supply voltage up to where diode can work properly, and up after, suppose this is after that, like suppose I'm giving you an example. Peak inverse voltage for this one diode is 10 volt. Okay, so if we'll give above the 10 volt, then in that case diode may be burn out or it will not work. So this is the peak inverse voltage. You have to remember the formula that peak inverse voltage is nothing, just Vs max. Okay, clear? Next one is the peak current. Peak current means maximum current, right? Peak current means the maximum current. So we can say the I max, right? And according to Ohm's law, what is the formula for I? I is equal to, tell me, I is equal to V divided by R. If I is maximum, then V should also be maximum. Yes or no? So V maximum means the Vs maximum, the supply voltage maximum, divided by, we are having two resistance here. One is the resistance for the diode. Okay, why then they have denoted by F? Because that diode is known as freewheeling diode. That diode is known as freewheeling diode. This diode, normally this diode they have said freewheeling diode. Why they have said freewheeling diode? I'll tell you that concept later on, but for now you have to remember this diode is known as freewheeling diode. So one resistance is this one of diode resistance and another resistance which is present in the load. So how many resistance are there? Two resistance. One resistance which is present in the load, that is denoted by RL. Remember RL that we have studied in the electrical, that is to know load resistance. Okay, and one resistance is present in the diode. So diode resistance is denoted by RF and load resistance is denoted by RL. Are they connected in series or in parallel? They are connected in series. So it would be what would be the value here? RF plus RL. So this is the maximum current. Okay, clear this thing? Okay. Next thing, third thing which you have to remember, DC output current. DC output current, can you tell me? Like as you know that this is the rectifier. So rectifier is converting AC to DC. So we'll get in the output DC current or the AC current. In the output means in the load side, we'll get AC current or the DC current. DC. So here the current flowing would be IDC because the current in the output side would be definitely DC. Rectifier converting AC to DC. So that's why they have said output always in the form of DC, and that is denoted by IDC. Okay. Now see what is the formula for IDC, that is 1 by 2 pi, because one cycle completes from 0 to 2 pi. So that's why they have said 1 by 2 pi, and integration of 0 to 2 pi, cycle again starts from the 0 and on to 2 pi, that would be I d omega t. Why omega t? Because on the x-axis we'll consider the angle, and that would be omega t only, like 0, pi, 2 pi, 3 pi. It is in the form of omega t. Okay, clear? So it would be 1 by 2 pi. Again, as you can see that there are two cycles. One cycle which moves from the 0 to pi, and another cycle moves from pi to 2 pi. So pi to 2 pi, you can see that there is no output. So output is how much? 0, right? So there is a only cycle from there is an only output from 0 to pi. So we can consider here, I'm breaking this 0 to 2 pi cycle into two cycle. One cycle will go from 0 to pi, right? And another cycle will go from pi to 2 pi, correct? 0 to pi and pi to 2 pi. And as you can see, pi to 2 pi is how much? 0, because we are getting no output. So that would be 0 d omega t. And in this case we are having the maximum current. Maximum current is the supply current. So supply current is how much? You know that supply current is is, and is would be equal to how much? Standard equation, that is is equal to I max sine omega t. So is equal to I max sine omega t d omega t. Okay, so that would be 0, that would be neglected. If we'll solve it, then that would be 1 by 2 pi I max. What is the integration of sine omega t? Yeah, integration of sine omega t is no, not by, because we have differentiating with respect to omega t, not t. If we have differentiating with t, then in that case we'll consider by omega. Okay, so the limit is 0 to pi. Clear? So if we'll solve it, then we'll put cos minus cos pi minus 0. After solving it, I am telling you the final answer, that is idc would be equal to I max by pi. Okay, clear? So idc would be again I max by pi. In the last case we have calculated the value of I max, that is vs max by rf by rl. We can put this one also. I max is how much? That is vs max divided by rf plus rl, that would be 1 by pi. So you can use both these formulas, that depends on the question which value they have given. If they have given I max, then use this one. If they have given these values, then use this formula. Okay, clear?